used to evaporate 5 grams of liquid at its boiling point. Calculate the specific latent heat of the liquid. Example 9. All the heat generated in a 5 ohm resistor by 2 amp flowing for 30 seconds is used to evaporate 5 grams of liquid at its boiling point. Calculate the specific latent heat of the liquid. Solution. Let L be the specific latent heat of the liquid. Electrical energy generated is equal to IVT, which is also equal to L squared RT, which is equal to 2 squared times 5 times that, which is equal to 600 joules. Heat absorbed by the liquid at its boiling point is equal to ml, which is equal to 5L. Heat absorbed by liquid is equal to electrical heat generated. 5L is equal to 600. L is equal to 600 over 5, which gives us 120 joule per gram. Example 10. A piece of copper of mass 300 grams at a temperature of 950 degrees Celsius is quickly transferred to a vessel of negligible thermal capacity containing 250 grams of water at 25 degrees centigrade. If the final steady temperature of the mixture is 100 degrees centigrade, calculate the mass of the water that will boil away. Specific heat capacity of copper equal to 400 joule per kilogram per centigrade. Specific heat capacity of water equals to 4.2 times 10 raised to power 3 joule per kilogram per Kelvin. Specific latent heat of vaporization of steam equals to 2.26 times 10 raised to power 6 joule per kilogram. Solution. Let Ms be the mass of water that will boil away. Heat loss by copper equals to mCC in bracket theta 2 minus theta 1 is equal to 300 over 1000 times 400 in bracket 950 minus 100, which gives us 102,000 joules. Heat gained by water 25 degrees centigrade to 100 degrees centigrade is equals to MWCW in bracket theta 2 minus theta 1 is equals to 250 over 100 times 4.2 times 10 raised to power 3 in bracket 100 minus 25, which gives us 78,750 joules. Heat gained by water on boiling is equal to MSL, which equals to ms times 2.26 times 10 raised to power 6, which equals to 2.26 times 10 raised to power 6 mLs. Heat gained by water equals to heat lost by water. 78,750 plus 2.26 times 10 raised to power 6 ms is equals to 102,000. 2.26 times 10 raised to power 6 ms is equals to 102,000 minus 78,750. 2.26 times 10 raised to power 6 ms is equals to 23,250. ms is equals to 23,250 over 2.26 times 10 raised to power 6, which is equals to 0.010286 kilogram or 10.3 grams. Revision work. Figure 2.5 shows a graph of force on the vertical axis against distance meters on the horizontal axis. A force varying with distance acts on a body as shown in figure 2.5. Calculate the work done on the body by the force during the first 10 meters motion. Solution. From the graph, distance of the first 10 meter produce a force of 10 Newton. From work done, W is equal to force F times distance S. Work done is equal to 10 times 10, which is 100 joules. Question 2. A 500 kilogram car which was initially at rest traveled with an acceleration of 5 meters per second squared. Calculate its kinetic energy after 4 seconds. Solution. Since the car was initially at rest, U is equal to 0. A acceleration is equal to 5 meters per second and T time is equal to 4 seconds. From the first equation of motion, V is equal to U plus 80. Therefore, V is equal to 0 plus 5 times 4, which is equal to 20 meters per second. From kinetic energy, half mv squared. Therefore, Ke is equal to half times 500 times 20, which gives us 10,000, 100,000 joules, or 10 raised to power 5 joules. Question 3. A body of mass 50 kg is held 3 meters above the ground. What energy has it before it is released? Take G equals to 10 meters per second. Solution. PE, that is potential energy, is equal to mass m times acceleration due to gravity G times height h. PE is equal to 50 times 10 times 3, which is equal to 1500 joules. Question 4. An engine raises 100 kg of water through a height of 6 meters in 20 seconds. What is the power of the engine? Solution. Power is equal to work done over time taken, which is equal to work done is mgh over time taken is T. Substituting the value, we have 100 times 10 times 60 all over 20, which gives us 3000 watts. Example 5. A plane inclined at an angle 35 degrees to the horizontal has an efficiency of 50%. Calculate the force parallel to the plane required to push a load of 120 Newton uniformly up the plane. Solution. Mechanical advantage MA is equal to load over effort, which equals to 120 Newton over effort. Velocity ratio VR is equal to 1 over sine 30 degrees, which is equal to 1 over 0.5, which gives us 2. Figure 27 shows the body on an inclined plane of 30 degrees with a weight of 20 Newton. From efficiency, E is equal to MA over VR times 100%. That is 50 over 100 is equals to, that is the efficient, is equals to 120 over effort times 1 over 2. By cross multiplying, we have 2 times 50 times effort is equals to 120 times 100. Making effort the subject of the formula, we have 120 times 100 all over 2 times 50, which will give us our effort to be 120 Newton. Question 6. A car screw jack is used to lift a car whose weight is 8,800 Newton. The bar for rotating the jack is 0.21 meter long and pitch of the screw is 2 mm. Calculate the efforts required to operate the screw jack, assuming 50% efficiency. If the bar is rotated 10 times, how far will the car be raised? Hence, calculate the work done in raising the car through this distance.